welcome you all again in today's Industry Connect live session. And we will be starting soon. So I see that still people are joining in. We'll just take a minute or so that others can also join. Um Meantime, as you guys know that these sessions we do in order to make you guys connect with industry folks, and these industry people are especially our alumni who are working and dealing with some real-time use cases, and so that they can share their knowledge and journey with you, and you can get inspired from them. And similarly for today's session, we have one of our alumni, Devaraj, Thejasvee Devaraj, who works in Swiggy as a data scientist, and overall he has 5+ years of experience. In Swiggy, he has been working from last 3.5 years and dealing with some really challenging real-time use cases, which he is going to share with us today. And in a minute, we will have him on the forum and we will get started. Hey Tejasvi, how are you?
Hi, how are you doing? I'm doing great. How about you?
Good, good. Thank you so much. Thank you for accepting our request and taking out your time for today's session, Tejasvi. Really grateful.
Okay, sure. Yeah.
So, Tejasvi, as I was telling, our students that these particular talks and session that we do, it is mainly to connect our present batches with our alumni who are now industry, become an industry person and can give them real-time experience and suggestion, because these people are in line to transform their career into data science like you did few years ago, right? So we think that connecting our alumni with present batch student is a great way and much needed thing to do so. So we would definitely like to hear about your transformation story first. How did you started? I mean, the course, when you joined the course, then what was your background? Then how did you transformed yourself, your career into data science? So all these, brief information we would like to hear, and then we can start with today's topic.
Sure. So, about my journey, right? Yeah.
Yeah.
So, I did my computer science engineering from an Anna University affiliated college from a town nearby Chennai. So, most of my interest was towards coding and developing web applications, mobile apps during my college days, I could say. So that's how my career started. And only thing I was interested in was bit of math and more of coding part, not many other things I was interested in. So that's how my journey started in my college days. And I used to learn whatever it gets to my way, right? I learned C, Java, JavaScript and HTML, whatever it comes to. I used to learn the basics at front and SQL. So that's how things were. So once I completed my college, I joined a startup which mostly works on banking business intelligence product. We used to deploy our product there, and it was towards mostly ETL jobs. I mean, people would have learned, right? Extract, transform, load, all these ETL jobs, and developing a business intelligence product for banks. So that's how my first year of work towards, that's where I learned more about the data and how the banking systems were. And I also learned about the coding part of SQL and Pro-C programming. That's initial stages, but that's when I got an interest more about that time. Frankly speaking, I didn't know much about data science more, as my journey was more about this data related and transforming it, data warehousing. So that's when I got to interest about big data, Hadoop world, and people are talking more about. Today we talk about data science, right? During that day, it's not very far. It's just 4.5 years back, but things are moving very fast in data science world, the technology world. So so okay, let me learn big data. Okay, let me go through it. This is my career, initial stage of my career. So I thought, okay, let's learn something new. So that's when I was started exploring. Okay, let me do MS or something new, but I want to do full-time classroom training. That's what my major focus was. It's more than getting a degree. I want to learn. So while exploring that, I also came across with INSOFE and the people who are teaching in INSOFE. I got really inspired. Oh, that's great. Really, I was reading about the reviews and I was like, okay, this is a 6 months course. Okay, I don't want to spend more time also. I can have 6 months course, which is specific to learning itself. So then, yeah, so as I joined, right, yeah, there was one curriculum on big data, yeah, vastly on the data science perspective from the basic math and basic statistical techniques and machine learning and advanced ML. And that's where we learned about those times the neural network started in the production industry, where industry experts were teaching us. So that gave me a base on knowing things, how it was, and how math can be work in real world. All that, that's where I learned, I could really say. And that really fascinated me. So then, yeah, before completing my course itself, I ended up with an offer from a startup, which is an women's e-commerce. But I'll not say, as I went there, the first day I started working on whatever I learned here, I was able to implement this data science, okay, algorithms. That never happened. Probably, I don't think so. It can happen to anyone, even today, because the first thing you go, right, you need to do a lot of other stuff. Probably that's what I want to talk more today here, giving an understanding what other things people would really require in the industry. And people should not be more worried about, okay, I'll do only algorithms, machine learning algorithms. That should not be only goal. So that's the major thing. So yeah, so where I started with data pipelining, making data streamlined, understanding how e-commerce works, what all the people requirements, understanding the reports. I mean, reports, it does not mean you are writing a code and you are generating the report. You need to feel the data. So you need to understand what's happening with the business. So that's how it started. Once this part is finalized, right, then we set up things of, okay, let's do some data science stuff here, build algorithms that could make people's life easier, and we could improve revenue or conversion. So that's how it started. So probably I could say after completion, it was a year of experience in the first company. Then I moved on to Swiggy. So I could say that's where I seen the real data, how the data was, and how anything we do can impact a customer in a good, or any small bad mistake could impact a customer. So, and given Swiggy, right, we were solving different set of problems, from recommendation, from customer segmentation, churn prediction, demand prediction, fraud detection. So there were wide variety of problems. Till even today, given a big team, there are other set of problems we are trying to solve for. There are unsolved problems that we are trying to solve it. So this is my journey, I could say. So yeah, I could take a pass, probably moving to the slides.
Nice. Interesting to know, Thejasvee, when, from the point where you didn't have idea whether you want to get into data science or not, but now you are a data scientist. So very interesting journey it might be. But now we can start with the session, and today's topic is very interesting. I think it will interest to all the participants. Data science project life cycle, yeah, definitely, and useful for everyone and in every domain actually. So we can start with the presentation right away. And meantime, if students, they have any questions, they will be posting into chat box. And whenever you want to take a pause and want to look at the questions, you can do so. Or towards the end, we can pick up all the questions, whichever way is fine with you.
Sure. So yeah, let me get started with the presentation. I'll share my screen.
Yes.
So today's session, it's more about the data science project lifecycle. What are the steps involved in each stage of a data science, any project if you take, and whatever we would have learned in a course or a course curriculum, we get a data and we directly go build a model and see the results. But if you want to do develop a model or in a production, how much time it takes, what are the steps it takes, that's where I want to concentrate more today. And I'll be also sharing the technology stack involved. What are the different technology stack? Technology stack, I mean, what are the different tools and programming languages we will be using in the process of building a data science project. That is one step I'll be dealing with. And I'll be briefly talking about data science projects in e-commerce. And I'll give a brief intro about how the e-commerce generally works and their applications. So that's my today's agenda, actually, the project lifecycle application. And then we can take a questions from the participants. So,
Right.
So I'll go to the data science project lifecycle, right? So in a real world, right? So normally what happens is there will be a requirement from a business or a project management or a product management team stating that we are facing some problem, or we want to solve an issue, or we want to make a customer life better. Nobody is going to give us a direct problem statement. We would have seen, right? Can you, for example, in a banking, nobody is going to say that this is the data set. Can you predict this customer gonna pay the loan or not? The problem statement would be totally different. So it'll to drill down to that problem statement, we need to work it out. Similarly, in any e-commerce world, for example, if you take any fraud detection algorithms, right? Nobody is gonna say, I haven't, this is the data, this is the target variable, you need to build an algorithm. That's that's not the way it happens, right? What we could expect is there will be a product or a business person who vaguely or sometimes does not understand much about data science, but there will be a requirement from their end asking for, see, there is an abuse or a fraud happening in our system. We got to know about this through customer interactions, or some of the vendor told us, or we have directly faced it ourselves. So that's how vaguely we get a problem statement. Sometimes we get a clear problem statements also, but let's focus on this, right? When you get a problem statement like this, you need to, you don't know what is the impact of the problem statement. Probably that could be very, very small scale, or that could be in a bigger scale. We tend to lose a lot of money for any firm, or it could be any e-commerce firm, or it could be banking firm, or it could be any case, right? So first of all, once you get this right, you formulate the problem. What you're gonna really solve for. So let's say there people say, if you take an Amazon, right? Probably people could malfunction the products they get, and they say my product is not good, and they remove some set of products and return to the seller. So this could be a small use case for an Amazon. In a scale it is dealing with, how do you really figure it out? So first thing, right, you formulate the problem. Okay, there is a customer transaction happening, so he's paying through in a different way. Probably customer could normally pay through a cash, or in these type of transactions, and ending up returning the product, which is after doing some malfunction in the product. So this is the problem statement. So that, okay, you define, okay, we understood this is what is happening. Then you define what you're going to solve for. Let's say you know this the problem statement is happening, the target variable is these people. So whoever asking for refund, there could be good customers, there could be some very few set of fraudulent customers. So you know this is the problem statement you have. Then you define the metrics. So the metrics could be two, right? So in a data science, this could be a classic classification problem. So you could have it. The model metrics could be, as this is an imbalanced data set, right? The model metrics, we could have seen the precision, recall, what is the F1 score. So we need to define what we are targeting for. So that is the model metric, which we're going to solve for. Then what is the business metric? So business metric, solving this problem, how much gain you're going to make. So that is more important. So that is also important. Plus, in this doing that, you should not affect any good customer. So that is also important. So our algorithms is not going to be 100% right? There will be some mispredictions happening. So we need to define these two things. How much we are okay with to deal with. We're gonna let's say hamper small set of customers for saving this much money. How much we're gonna be okay with, the business gonna okay with. So that is one business metrics we're gonna solve for. and what is the model metric, how much pressure we need to have, how much recall we need to have. As this is some fraud prediction, right? Probably in this example, we might be focusing on a higher pressure rate. So we need to be right. Whenever we say someone as an abusive or a fraudulent, we need to be always right. The pressure should be, let's say, we could be expecting around 98 to 99 or something of that range, or plus 95%. That's what we could be focusing on. So it changes from problem to problem, right? For some problems, the pressure could be lower, or we could be targeting for higher recall, all that. So it changes from different problems to problem. So first is the problem formulation, then defining what model metric, what is the success, what we're going to call success as. So in terms of both model, in terms of both business. So once we have done this, right, we're going to estimate the impact. Because let's say there could be like, I mean, for as a person, as an individual, we are seeing at one set of problem, but as an organization, right, it has hundreds of problems to deal with, and it has a limited set of resources. The engineering will be limited, or the time we have is limited. So we need to understand what is the impact of the problem. I mean, if we're going to solve this, so let's say we're going to save this much money, or we're going to get this much conversion, or we're going to make this much customers happy. So we're going to have all this estimated cost. If we solve this problem, we're going to have this estimated savings or conversion, or it could be anything, right? And we need to compare with the other problems. So, I mean, there could be other problems which is more serious, which could be giving a higher conversion in any e-commerce, right? Conversion, I mean by whoever comes into our platform goes away purchasing something. So the conversion should be, so it's not that all customers who comes in ends up with a purchase in a platform, right? So if only the customers makes a purchase, we end up getting some money out of it. So there are 100 problems. We need to understand what is the estimate impact, how much this problem, if we solve this problem, how much gain we're going to get. So based on that, we will be choosing a problem to solve for. So once all this set, right, we are now sure, okay, we have a problem statement, we have a business metric, we're going to solve, we have an engineering effort and analytics effort, data science effort, business effort involved, everybody is aligned. Okay, let's decide it, we're going to solve this problem. Okay, that's the first, we have just arrived, we have not even gone to the problem, we have just, okay, we have made sure we're going to solve this problem for. Probably I'll take a minute or so. If anybody have a question here, I could answer that. So yeah, so let's go to the next step actually. So the major part here, right, the data gathering part. So if you would have solved any problem, right, a data science problem in a course or in an, let's say in a Kaggle competition, you would be directly getting an CSV dump where you have exact rows and columns, and then predictive what you're going to predict for, if it's a supervised algorithm. If it's an unsupervised algorithm, even you get at least the X variables, what you're going to solve for, what you're going to cluster the data for, what anomaly you're going to predict for. So, but in the real world, that does not going to happen. So you're going to find the data at different places, right? You need to understand where are the data excesses. So before going here, right, I'll try to give a generic idea how the data is going to be for an e-commerce firm. I'll just move one slide. I'll just come back here again. So I'll just, for any e-commerce, right? So that's the funnel. So funnel, I mean here is, so a customer ends up in a product listing page, or he might search at the product. Then once he finds the required product, then he moves on to the menu, and then he adds that product. Okay, for example, in Swiggy's context, a person go to a restaurant. Then after he finds a restaurant, he goes to the menu, and in menu, what all items he required. Let's say he want to add a pizza, or it could be shawarma. Whatever items he required, he adds that. Then he moves on to the cart. In cart, he might want to add, find out if there is any discount or coupon he could apply. Once that is applied, the final cart will be there. Then he goes to the payment page. He chooses the payment option, then click payment. Once that happened, then he moves on to the checkout. So in this funnel, right, it's not that, let's say in product, we got 100 people, all these 100 folks are going to move to the menu, or there are going to be drop-offs. So let's say there are going to be 100 people in product listing, probably an 80 might convert to menu, From menu to cart, there might be another drop. So that's how the funnel gonna be. Sorry. So in every stage, they're gonna drop off. So our any e-commerce focus should be to improve this conversion. So let's say there are gonna be 100 folks coming in today, and 80 folks are going to the menu. How do I make sure my all folks, I mean 100 folks coming into here, at least how do I improve the conversion from 80 to 90 or 85? So that's how our focus should be. So there will be different algorithms in place to do that. So this is the basic e-commerce funnel. And I'll also give a basic idea of the data, right? In any data world, we're gonna not get data, as I told, in a correct or CSV format or an table format that we're gonna take directly and put it into an model and get the results. Or, I mean, there might be pre-processing, but still we are not going to get that data as such. Right? In any e-commerce world, the basic data would be the customer. Whoever registered with us, we get the customer transactional customer data, the basic customer data, and the transaction data. So we're gonna have a customer data. Whoever registered with us, we're gonna get store all the customers' data. Then once that registration happens, the customer gonna do a transactions with us. So it could be a transaction ID. So here, whoever registered only can do a transaction. And so one customer could have many transactions, that possibly. So then this is the basic structure of a data, right? And it's not just that, right? We're gonna save all the data possible, whatever the customer does in an application. So if you could think, right? So it's like all these funnel stages which I showed. Whoever comes to that listing page, whatever he does, what all project he sees, in what page, how much time he spends on, and what all menu he adds to. So all these stages of funnel also will be saved. And also the static information, like product information. So we could have thousands of products in any e-commerce, or millions of products. All this product static information will also be stored, and the product owner's information will also be stored. And other than that, the transactional data, right? I mean, the delivery information. Who is the delivery partner who gonna deliver this product to one place to other, and how much time he gonna take? Everything will be stored in different places. So that's how our basic data gonna be. So in this case, right, if we have a data like this, we need to be deriving so this is the data gathering part, understanding where our data is. Once we get to know that, then we do some basic analysis on our data. So let's say if you have a problem on the refunds, a customer coming to our platform and asking for a refund all the time. So we need to understand what percentage of people are doing that. In that, what percentage of people are new users, old users, and which city is majorly coming from? And is there any specific areas people are doing it? And is it like, is that a repeated behavior on the same customer? Or is it like every time one customer creates an account and asks for a refund, then disappears? So all this basic analysis of the data, we need to explore and understand how the data it's gonna be. So what does this help us? So once we do all this analysis, right, this is what helps us to develop our features for our model. So let's say we understood, let's say the city wise, we're gonna see a difference. This specific city has a lot of abusive behavior from understanding on getting a refunds or canceling an order. So we understand all this. Okay, let's say the city is an important variable, or a new user or an old user is an important variable. So given doing all this exploratory analysis, you come up with an features which can be used for our model. So that's the next stage. So that's where we normally start any course, right? We get all that data set. So based on this, we try to build our data model. In that also, right, the features can be split into 3 sets. So 3 sets I mean hereby. One is an historical data, so and then near real-time data and a real-time data. What do I mean by historical data? So historical data are normally in terms, right? So it could be like whatever happened till yesterday, probably in any e-commerce world, we try to solve that way. I mean, you could say last minute also is historical, but still for the sake of simplicity, how we gonna store our data, right? So how will we normally do is, let's say you're gonna predict for a transaction, what happened in that transaction. We need to, let's say the customer is dealt with that transaction, right? If you see in this data, there is a one customer, for example, in this transaction, one customer, customer ID of, for example, 367 has done a transaction. You need to predict for this transaction, if he has asked for a refund, is he fraudulent or not? For that, we need to aggregate his historical behavior. If you could see, he has done some 3 transactions historically. So you need to derive that feature and add that as one column. So what that column will be, how many orders this customer has done historically. So this 367 customer, before this transaction, I mean the 009 transaction, he has made 3 transactions. That will be one historical variable here. So for the prediction. Similarly, there will be something called real-time variable. So real-time, near real-time variable. Near real-time variable, I mean by, let's say, probably I told you, right? What happened in last 1 hour? What the customer has done in last 1 hour, or what a restaurant has done in last 1 hour, or what a delivery boy has done in last 1 hour. So we will be saving that data also. We'll be using different tools for different data, right? So I'll be explaining that in the technology stack. Then the real-time variable. What do I mean by real-time variable, right? In this data, we could see the bill amount. Bill amount, you can't know historically, right? You can know only when the order is being placed. So that is a real-time variable. It's happening right now. So that when you're gonna infer, so you built a model, when you're gonna infer that, right? So you're gonna get it in the real time. That second you're gonna get, that millisecond you're gonna get. And so that is gonna real time. And you will be in the real time variables also, you will be deriving something. So you can't use just ordered time. So this is a date format. Model can't understand that, right? Probably you will be using. So what is the day of the week? Is it a weekday or a weekend? So that you can derive from one variable order time. And for this order, how much time it has taken from order time to ship time. And so you can find the difference. So it took like 3 days. So that variable will be deriving from the ship time to delivery time, how much time it has taken. We'll be deriving that variable also. So we need to derive a lot of variables like this from the base data before going to the model. So that's one of the important step, right? In probably people would say more than 50 to 60% of time goes with this actually. So deriving the variables and finding the right variables, all that time we majorly take here. I mean, it also consists of data analysis, exploratory analysis also. So that is our major part. So once we have derived all these variables, right, then we go to the feature engineering part. Feature engineering, I mean by the imputation that you probably would have learned, and the scaling the feature. It depends on model to model. So probably a linear regression, you might scale. For a decision tree, you might not scale. So it depends on, it varies from problem to problem, what you want to do. For a k-means or clustering problem, you need to do scaling, and what kind of imputation technique you want to do. It also, the imputation does not only talk about, let's say if you want to impute, right? So it does not go only with the data. You also need the business sense. So what you want to impute for a missing value. So we normally would have learned about just, okay, we could do nearest neighbors imputation or a mean or a median imputation. That will also help, but yeah, we need to also have a business sense on imputing. So that could also be very helpful on the imputation data. So once we have all this and we have the target variable, and we have seen the model perspective of finding the correlation between the data and binning the data. Probably there is a data, if you want to bin the data into groups, you will be doing all this stuff and doing one-not encoding on the data. So, and even in one-not encoding, there might be some variables you need to be removing. All that once this stage is set, right? So that's where you get that final data for training development. So once you have that, you will go for model training, try out with different modeling techniques and hyperparameter tuning. This 2 parts you would have learned it. So the major part I want to discuss more here is the model evaluation. So probably with respect to, let's say, in terms of, let's say model metrics. Let's say we call accuracy. So what could happen in the real world is when you see overall as a model, let's say you built a model for an predicting a time. Let's say you work for a Google, you need to predict the time whenever a customer selects to location A, location B, and you need to be able to predict the time, what time he will be reaching that the destination. So in overall, you see the error rate is very, very less in an overall way. But what could really happen here is it could behave differently for different cities. Probably you are very accurate for USA and you're and medium for India. So probably you are very good at predicting USA's data. Your error rate is very, very minute. So the overall error rate is like 2 minutes, you could say, let's say for any 30 minutes interval. But for USA, your error rate is like 0.30 seconds. For India, it's 1 minute. But for any underdeveloped countries, right, your error rate is very, 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 very high. Probably, let's say 10 minutes. So for a 30-minute prediction time. So I'm not talking about overall, right? Let's say the destination A to destination B normally takes 30 minutes. In USA, the error is like very less. India, medium. And other undeveloped countries, you could see their error rate is very, very high. So what could happen is if you deploy that model, probably you are performing better at few places, but you are performing very, very worst at few places. So this could lead to a lot of serious problems. So in that case, you need to understand your model evaluation in different segments. So so you need to understand your model performance with respect to cities. You need to understand your model performance with respect to customer segments, how it is performing with a new user, how it performing with a user with started as 10 orders, how it is performing with a user with a very, very high number of orders. You need to understand all these perspectives. So then only you can deploy a model in a production. I mean, it will not be at live, but I'm talking about you can deploy, take the engineering effort and you deploy the model in production. So after understanding all this, so that's very, very important. This is key. I am like saying this twice because this could lead to a lot of serious issues in production. So once you have done that, right? So for training, you have done all this data preparation offline and the model training in the offline. So you need to, what you need to do next is, in order to put your model in the production, you need to have features running every day, right? So you need to set up a con for historical features. Let's say I want a feature like for a given customer who is doing a transaction today, I'm gonna do a prediction today. I need to understand this historical transaction in last 2 months. So what do I mean here is how many orders a customer has done in last 2 months. So that you need to set up a cron and it runs every day and stores in some space so that your model can take that data during the inference time. Inference, I mean by the prediction time. So that crons you need to set up for the historical variables. Similarly for near real-time variables. So you need to understand. So for historical variables, it might be running every day. Near real-time variable, it might be running every minute or every 2 minutes, seeing last 1 hour what is happening. So it will be changing its hop. Let's say your data is like this, you are here, your prediction is here. You need to know what customer has done in last 1 hour. So you will be doing this hops every 1 minute and storing its data, because you will be storing for all customers, because you will not know for what customer gonna order now, right? You can't predict. I mean, probably we could predict, is this customer going to order today, but there might be possibility you will not be able to know all customers you're going to order today 100%, right? So you'll be storing for all the customers in a specific place who have done an historical orders. Similarly for near real time and for real time data, right? Real time data which happens right now. How do you get that data? So normally what happens in any world, right? So it comes through an API. So API call, I could say. So our model is an API right now. Think it's a function. And let's say somebody is going to hit our model. So the Google, what we're going to, I mean, we are using a Google Maps, right? We're going to give the inputs. Location A, Chennai, location B, Bangalore. So how much time it's going to take? So it's going to hit the Google system. It's an API call made through us, and it's going to give the prediction. So what we are doing here, we are giving the inputs. What is the input here? Input is the locations and what time we are calling the model. These are real-time variables. This Google can't know historically itself, right? Tej is gonna ask for this prediction at this time, all that. So it will be a real-time variable which is flowing. Based on that, it has some historical variables like how for this timing historically for a bike, how much time it gonna take. I mean, it has taken. So let's say historically it has taken around, let's say 7 hours for Bangalore to Chennai during this time. And based on this, right now, what is the traffic? It will be also taken, which is a near real-time variable, right? The near real-time variable is a traffic. Historical variable is historically for this time ranges, for this weekday or weekend, how much time it has taken. Real-time variable here is the locations and the exact time when I have requested. So this will be flowing to the model. So all this need to be stored and some variables coming in the real time. Once this is done, right, you know, okay, we have deployed our model finally, everything is done. It can be consumed by the user. From Kavita, right? How do you estimate the impact, right?
Right.
So that's a good question, actually. So normally what we do is, right, we can't give the exact impact, how much we're gonna solve for. So what we normally do is, right, so let's say if you take a fraud prediction or a recommendation, so it depends. So when you do the analysis part, right, let's say you know how much cancellations or how much, let's say, refunds people are asking for. So let's say, for example, in any e-commerce, let's say the 5% is the cancellations generally happening. So while doing the analysis, you understand the different customers' behavior. So you could come up with an hypothesis, probably these set of customers might be fraudulent, or these set of restaurants might be fraudulent or abusive. Based on that, how many orders they have done, you come up, okay, these many orders they have done, these many were cancelled. So this is leading to this much impact. So probably that could be one use case. Similarly, for a recommendation, right? You build an algorithm, right? So once you build an algorithm, you will know how many are going to convert. So how many are going to actually place an order from this restaurant or from what a product which I have suggested. So in that sense, you might estimate the impact initially before developing a full-fledged product. So that's what, but that might not be actually right. I mean, exactly the same, but it will be in that range. Let's say I'm going to save a cost of 5 rupees for all orders. Let's say you're going to have an impact of that. And similarly, I could say, given this algorithm, we're going to have, based on this customer behavior, based on the techniques we're going to use, we're going to have a, incremental conversion of 2% or 3%, 1%. That actually comes from the data analysis part itself. So hope I cleared your question, but yeah, it totally depends, changes from problem to problem. And yeah, could you touch upon the data quality and data simulation part in reality? Yeah, sure. Actually, yeah. So I'll try to answer that end also, right? So in initial days, for any startup, I could say probably you would see a lot of data issues. So probably you will be thinking in some way, let's say you are collecting data from mobile phones, right? You are collecting data from Android, you are collecting data from iPhone. It will be saved, you said, let's say you're gonna collect a device information or anything you're gonna collect in any world, or what is the mobile phone model you are using, something of that sort you are collecting. At least the transactional data, you will not find any much issues, because that is actual data which gonna save. But when you are collecting other informations like the device the customer is using and what time he has actually, how many times he has browsed, it's a huge data. So, and from each device you get a different type of variety of data. iPhone will give you some kind of data, Android would be different kind of data. But if you merge it and see it, right, and you might see a different information coming in. So when you take that data and model it, right, that will lead to a different prediction and lead to a mispredictions also. So you should be spending time on the data quality check also. So how do I do it? How do I do it is mostly when you do that analysis bit, right, when you try to understand data, you will feel something is fishy. Then you go and raise it to the engineering team, whoever is collecting the data, and tell them, okay, there is some issue I can feel. There is this data which is collected seems to be wrong. How do I correct it? I mean, that's information gonna be communicated to an, what to say, any engineering team who is collecting the data. That's more important. I could give an example, right? Let's say you're gonna collect information about a IP address, let's say. For some, let's say you are collecting from for some specific data, you are getting same IP address. Let's say for some specific city, all the IP address you have collected is same. So what you will know, that can't be possible, right? As a human, I mean, if you analyze the data, that can't be really possible. So you will end up providing a bad data to the model. So your model end up with a bad prediction. So you need to, when you do the analysis, you need to you don't believe the data always. We know we are collecting a lot of data, but be sure there are data issues, quality issues. We need to keep track of that and communicate it periodically. And it also changes. Every time it changes. That is very important. Good question, Hari. Kaushik, yeah. Cross communication, yeah, that is very, very important. And for any pod, right? How do you simplify your data? What data science model you're going to communicate to it? Probably a data engineer, BA would be different, but you're going to communicate to a stakeholder. You need to be pretty sure on how do you communicate. You need to simplify as simple as possible. Then that's when your product gets launched, because they are the final product owners or business consumers who need to understand our product. So that's very, very important. And as far as I've done, right, it took like a lot of time for me explaining this precision recall to my business stakeholders. I need to, okay, this is precision, this is recall, this is false positive rate. So you need to take time and simplify it. And one more point there also, right? You don't need to explain everything. You need to know what things people need to understand, what data engineers need to understand. You need to communicate in their language. You need to know what BA team understand. You need to communicate in their language. Similarly for stakeholders, it could be a product. For a product manager, you communicate in a different language. For an a business user, communicate in a different language. For an engineering team, you communicate in a different language. So that's very important actually. It's not just visualizations, actually speaking. So it's visualizations, it's just a tool understanding the data, right? So if you want to understand data, you could just put a tabular format also, you can understand data, and you can do a lot of plots to understand data. It's just a way you're gonna understand data, that's it. So we could have studied, okay, we do matplotlib and do all this timeline plots, distribution plots, bar plots, all that we do. But what do you understand from the data is very important. So you could do from R, Python, you could do even Excel. Probably Excel, I mean, that's way powerful. If you want to do a faster analysis, right, you do it from Excel. So understanding data is important. It's not how you're going to do it, but you can learn it. We have Google, we have Stack Overflow. If you know what you want to understand, that's very important. And data visualization is a way you understand the data. Yeah, so we normally don't deal with, we also have a structured data. So structured data, in that itself, we have different things, right? So it's not that a transactional data, you could easily store it in normal relational database. It's way structured, and there will be images, all that will also be there. But we are trying to explore in that part. But in the structured, mean by a textual, I mean, tabular data itself, there are other forms of data we store it. So let's say you're going to scroll any page, right? It's not easy to store for every customer in the same way, because a customer will scroll 10 pages, other customer will scroll 1 page. He will see 5 restaurants, he will be seeing 100 restaurants. So it's a different way of storage. How do you extract information from that? You need a lot of skills on this SQL or a Spark we'll be using mostly. So that's one part. But yeah, we are trying to explore on images, voice also, but we are not yet there. We have started it, and yeah, there are other teams who are actively working on it. But as far as my my what to say, projects I've worked on, I've not much worked on images and voice data. Yeah, so we normally, I mean, based on business, we can't change the, I mean, business understanding, we can't change the feature importance, right? And there is one point I want to talk about here, more on the feature importance, as you, maybe feature importance. Yeah, okay, got it. Yeah. So on the feature importance, it's not that a feature which has gotten higher importance. For example, you say, let's say it got top mode feature, which has higher importance, but a business user could say, this seems to be not much important, but a feature which is at the middle or at the 10th, for example, or at the 50th percentile or 60th percentile could be important. I'll tell you the reason, right? We can't generally remove a feature just based on the feature importance that we could have studied or we could have experienced ourselves. What could really happen is, how do you calculate a feature importance? Let's say take a decision tree, right? So let's take entropy as a measure or information gain as a measure. We see how much it gonna split the data into write-offs. Let's say there is a feature which splits on a cut, and all the features this side are 0, all these features, all these data points this side are 1. So that could get a higher importance. But what could happen really is, there will be a features which is at the 10th or even at sometimes at a last stage, at the last part of the feature importance. What could really happen is that feature will be important for predicting a small set of data. Let's say 2% of data, but only having that feature, you will be able to predict that data. So that is also important, and you can't just remove your feature based only on feature importance. That's very important. So yeah, it depends on the time estimate to stakeholders regarding a project deliverable. Actually, it depends on the problem usually. So the most of the time before committing on a project, right, we generally, the first 3 steps I was talking about, right, the problem formulation, understanding the feature metrics and impact estimation, right? That's where we're going to take the major amount, I mean, the initial amount of time. Only understanding that, we get an idea how much this project going to take. So once that 3 steps are done, we going to give an project estimates only then, not in the first step itself. So that will always give an idea how much a project time or estimate going to take. So, and understanding all the quality checks of the data, I mean, in production, right? So what we necessarily do is, once the model is deployed, everything is done, we again test the data. What do I mean by quality check of the data? So once you, because offline you have prepared the data, understood how it is performing, you need to have the similar data, similar way how you code it, even in the real time. So what could really happen is, let's say you could have a feature as a day of the week. So day of the week as a number 1 to 7. Okay, so probably what you could think is 1 is Sunday, but what engineering could think is 1 is Monday. So that could normally change overall how the model is, I mean, the model input is. So you need to understand, I mean, you will be all doing a quality check again on the data which is coming in before giving the model into production. I mean, you will be having the model in the production, but the customer, I mean, nothing will be happening on that. There is data, everything is, there is a call made to the model, but it's not shown to the customer. Nobody is getting impacted. So what we will do is, you will do a data quality check, how the features are written. Is it the same way how I have done it in the offline? Are there any null values in the real time coming in, or any data which can't be, which can't be coming in the data? So you will normally start with the distribution check. So how is the distribution in the production data, and how, when you made an offline model, how is the distribution? You will do all these comparisons. So that is what first stage on the data, right? I mean, what to say? The data quality check, and then a model check. You will understand the model performance again in the production. Based on this data, once features are right, is it performing the same way as I've got the results in the offline? Offline training and testing, I got some, let's say, accuracy of 90% or F1 score of 90 plus %. Is it same way I'm getting in the production also? So you will check that once again. Once that is done, right? So you know everything is right. So that's when you go and do an A/B testing. This is where you go and do a production. I mean, the customer, whoever is using a product, will directly get impacted from whatever we have developed. So what would really happen here is we do an A/B testing. What does it mean? Like there is a product already which is in place, and you have a new product coming in. You need to compare the results between these two products. So this is where we also understand the business impact also, because once the product is not even live, we will not know the exact, let's say, business impact. So let's say what the conversion is going to be, how much money we're going to save. So we could think as A/B testing like this, right? So let's say there is an Facebook we are using. So it's in blue, let's say. So let's say I'm going to implement other color for it. So how much time a customer is going to spend given this color? Or if I'm going to change a button from left to right, so what is the customer, how much is the customer happy with it? Our customer is moving to the next page. So everything will be based on an A/B testing, even a small business change or data science modeling, right? So every change in an application, we will do an A/B testing before giving that to, showing that to all the customers who are using that application. So what will happen is, let's say there is an A which is probably you could think as an previous model or a previous rules. Let's say we have a rules to detect fraud, or rules to rank the restaurant. Let's say which are popular restaurants, we have that restaurants in the top, or rules written to predict time. So something of that sort, we have written a rules. Now there is a model coming in. I can't show this model to the entire population. So I'll start with a small set of 5%, let's say, not even 5%, let's say we could start with very small in the initial first day, or 1 to 2% we would start with, depends on the impact it's going to have on the customers. So once that 2% is set and we analyze, compare the results on, everything is set. So then we improve the size of the test group and the control group, right? So we do a 50-50%. Let's say we have the 50% which is seeing the current rules or a current model, and 50% which is based on the new product. So we compare all the results. So why do we do an A/B testing? Why can't we do historically? This is how the model, this is how the conversion was. This is how the saving was, all that. It is because that is not apple to apple comparison, we say, right? So in this given situation, we have the same set of customers here. Same set of by identical. So there are customers, there are 10% of new customers here, 10% of new customers here, 20% of old customers from this city. So all the things are similar here. So in the city it's raining, it's gonna, there are customers, it's also raining here. So no other factor could affect this experiment. So we are pretty sure we are comparing apples to apple. So now let's say we are gone A/B, and we have a 50% of population here, 50% of population here. So we have built a recommendation algorithm for 50% of population, and there is a rules. Okay. So we're going to compare how people are converting. Given this recommendation algorithm in 50%, right? How is the conversion? Let's say there is a person coming into a funnel. Is he moving to the next space? Let's say right now, based on these rules, let's say we have done an A/B for 1 week, and there are millions of customers here, millions of customers here. So in this millions of customers, 90% of people were converted. Here, 95% of people are converted. So what we do here is we do a hypothesis testing. Yeah, we do test how confident we are. So you could have learned all this, right? How confident we are, what is the sample size, what is the margin of error. So we check all that. Once we are pretty sure, okay, this population is good enough, and this test, okay, there is a good impact of this new model, then we make this model 100%. So it's not that directly we build a model, we go live with it. We test, we do a lot of experiments like this. So in what happens in many cases, one model will be performing good for a specific city, and the rules will be performing better there itself. For example, let's say there is a very, very new city, which we have no data about that city, and very new customers are there. Probably a basic rule, popular, you have only 10 restaurants or 50 restaurants around. Probably a good rule of show the popular restaurants, that would be performing better. But there is a city like Bangalore or a Chennai, so which a very metro city, you could see a lot of customers. You have different ways of showing the data, there a better algorithm would be performing better. So it changes from cities to cities and the customer to customer. Let's say a new user who didn't have a lot of historical data, model might not be performing better. Similarly, for old users, it be performing better. So it's not that one model is for universe. So you will be building a lot of models for different set of customers. You will be doing a lot of experiments and understanding the data. So you will be doing a lot of A/B testing. So that's when you go the model into the production once you finalized everything. So let's say you are in production, you are not yet there. I mean, that's so you are in production, everything is cool, you have accepted. It's not that you are going to get a similar data, your data distribution is going to be same, and you're going to get the similar set of results from that model, right? You have trained the model and put into production. It's not that you're going to retrain every day based on the data, and based on the data changes, you're going to see it. And the feasibility wise, it's also like we are trying to, I mean, we are not yet there. I mean, people are trying to do an online retraining, all are there. So there is a one train model based on a historical data, which is in production, that's there. Now you go, the model is learned based on that. For right now, it's performing better. But once the distribution changes, let's say, what could happen to the model? Will the prediction change? Yeah, it's highly possible. Let's say there is, let's say you're going to do a rain prediction. I mean, you're going to do a prediction of the time in the Google map. You're going to have an historical data and you are predicting based on that. Suddenly there is a natural calamity and everything changed. Let's say COVID, right? So given COVID, entire, what to say, the way people order changes, everything changes. It's not that you can't keep the same data you trained last year or let's say 3 months back. You can't use the same thing. The COVID comes in, entire data distribution itself changes. How it was previously, how it was now, it's entirely changed. So you need to keep track of things. So you normally keep track of how our model metrics and business metrics are performing. It's not just the model metrics and business metrics you will be keep tracking of. You will be also keep tracking of the data which is coming in. So let's say, how is the distribution of the data? Is there the distribution continually changing? When you built a model for a, let's say you had a feature of average order value of a customer. When you built a model, the average order value of a customer is around like the mean is around 500 rupees, and the standard deviation is around, let's say 100 rupees. Okay, that's how your data was. And now as the COVID started, your distribution totally changes. So mean reduced to 200 or increased to 1000 as the number of customers reduced, and only comes to order when it's a high value order, something of that sort. And your standard deviation totally changes from 100 to, let's say, 300. What you would normally do, but meat might be 500, but your standard deviation totally changes. So your model is going to see a new, I mean, the distribution has totally changed, which is not ever seen at all. So you might end up in a lot of, what to say, so a lot of mispredictions. Your model predictions, the accuracy might come down, the error rate might come down, all that, I mean, error rate might increase. So all that could happen. So you will be you will need to set up alerts each and every hour, each and every day. You need to set up alerts from this range, it goes away. You need to have an alert. You need to keep track of that. So that's very important in any data science project. So, and it's also not the data distribution changing, the input you are getting, right? The cron you have set up, it could fail. So that there is a delay in data, the cron could fail, or table you are using could change, because let's say some models which will be for, let's say, 6 months. In that 6 months, the table name could change and it could move a different source. So what could happen? You will not get any data at all. So it will lead to what? Your feature is totally changed. So given that, you need to keep track of all the things, whatever you have done. That's when the data science model is in production. So you need to keep track of everything, whatever you have done. You need to think of each and every step. So one small change could affect the model entirely, and it could have a bad impact on the customer end, or it could be on a restaurant, or it could be of anybody using an application. So that's the, I mean, this is probably a life cycle. Probably I covered whichever I go through in any project we do, right? There are other steps also, but yeah, this could be a major skeleton, I could say, which any data science life cycle would follow in any project. And yeah, I just want to talk about the technology stack right here. So here on a technology stack end, it depends on the problem also. So normally what could probably we could use, right? I could give few examples what we done, right? So in any cloud, right, we store the data probably in any e-commerce, or it could be AWS, it could be Azure. We will be in AWS, we store the data in S3 buckets, and we create an Hive tables. So Hive tables will be created. That is the first source of any API data or any transactional data. It goes into an S3 bucket, then an Hive table is created. For Hive tables, Hive table, you will be querying from an Hive table. So generally for an faster queries, for an, let's say for analytical queries, people might be using Presto as one tool. But if you want to do in batch queries, let's say you want to set up cron, you need to think about the cost also. See, everything which we are doing, it's related to cost. The data you're going to store, everything is related to cost, right? So how much, if you are querying, you need to write that query right. So a small mistake in a query, a small join, a cross join, which will lead to dollars, waste of dollars for the company. You need to keep track of everything. That is also important, actually. So that is the first stage of data understanding, I mean, getting the data. So then for the model development, we generally use Python and for a real-time productionizing the model, we'll be using Spark, Scala actually. So, and as you see, right, we need a response of any prediction in milliseconds. Let's say you use any application, Google Maps, Swiggy, or it could be Uber, it could be Flipkart, anything, right? You do everything is based on an algorithm backend, and you can't wait, I mean, for seconds also, right? It need to be in milliseconds. And as you need to have this prediction in milliseconds, the model need to be able to do that, and it also need to have the capacity of data come flowing in milliseconds. So for historical data, fine, you're going to run it every day and store it at one space in memory, so that you can have a faster response. For real-time variables, so let's say I want a data in last 1 minute. 1 minute, what is happening? You can't wait till the data goes and sits in a table, then you write a code to get the data to pass to a model. This is during the inference time. So what you normally do here is the data come in streams, right? Before going to a table, before going to sitting in an S3 bucket, it comes in a stream. So you read from the stream itself and push the data to the model. So that's fast you need to be to make sure your model gets the data at the right time. So this is a general idea, I could say, the brief of the data storage and other technological things we need to be keep tracking of in our everyday life. That's way, and we need to know about the tools and the costing also. So let's say you can't use a local machine, right? We normally use AWS or Azure, their missions, how much it costs, how much a GPU cost, or how much a normal mission cost. We need to keep track of that also. I mean, that is also kind of important. I mean, to save cost from our and what we are using. So that is one thing. So yeah, kind of covered on the life cycle. So I'll briefly talk about the applications. I mean, probably I mean, in the life cycle itself, I gave an intro what all things could be. I'll briefly talk about applications, and I'll take few questions actually. So, yeah. So one question is from Mohit Jain, right? How do you decide when to retrain a model? Yeah, that's a very important question. So as I was talking about alerts, all that, right? So as we are keeping track of the change in the data distribution, and we keep track of the model metrics and business metrics. So we know, so when the model metric or business metric is degrading, or the data distribution is totally changed, we know that's the time we normally go for retraining. So it also depends on a problem statement, and also based on the situations like this. COVID, a model which is trained a month back could perform very bad in current situations. So that's how things were. So keeping track of the model metrics and business metrics. So based on that, we tend to retrain the model. Yeah, thanks for asking that question. Okay. We are not at their Mittal, right? So the question was, is there any online retraining? Yeah, probably we could think of that, but there could be a lot of implications of that, right? See, we need to keep track of metrics, how the model is performing. Let's say we entirely leave out, I mean, at this current stage, entirely leave out, okay, if you see, you can retrain based on new data and predict, I mean, change it. That could be causing us an, I mean, if there is one small error, we could lead to an, what to say, a big production issue. So normally we do a retraining offline and productionize it. We'll be shown there actually. I mean, there could be other organizations, or mostly we could be online retraining and comparing the results, but yeah, we are not yet there trying to build those products. So I'll give a generic idea how the interview process are, and yeah, so right now, right, so it normally what we need to be sure at is the first thing, whatever you learn, I mean the algorithms and the math, we need to be clear on that front, whatever it takes. So we'll try to revise that. Probably we might be calling APIs and using in real world, but we need to revise that or keep track of the algorithms of working and the modeling and the stats, the math, right? So that is 1-2 key parts. So other than that, people also, upon that, based on the levels, people also required to have this data understanding skills. So that can be probably called, yeah, do you know Python? Do you know R? But yeah, but using that, you need to build a model. And before that, you will be analyzing the data, understanding the problem. So that's also very important. So normally what happening in nowadays, right? Once the first set of initial discussions happen, there is a case study on how do you go through a problem. So that comes from the problem formulation. What are you gonna solve for? And then your data understanding skills, data analysis skills, understanding the insights in the data. How do you gonna feature engineer the data before throwing it to a model? So all the skills will be very important. And it's not that everybody needs to know big data, the data, I mean, everything, it's not necessary. That's probably we could say that's not possible also. We could know. So I would suggest go breadth, I mean, just know things. I mean, once you are sure, okay, you know algorithms and the math, right? And the data understanding would be the next thing. And then you try to go, what all tools are available, what is the big data techniques, all that you just know what are things are there. Then once you are pretty sure things are fine, you know about the just basic brief, then you go deep into what all things you want to read about. So that's what I would suggest. And nobody can know everything. I mean, even anybody, that's really hard. Once you get into the, I mean, and each and every company has a different technology stack, right? Few companies are using R, few companies are using Python, few companies for deployment, they will be using a big data, Spark, Scala architecture. Somebody using AWS platform, somebody will have inbuilt data science platform. So all these things will be there. So you have your basics, right? Always, you have your basics, right? Always in the coding side, you have your Python or R good, SQL good, and using that you do a lot of case studies by yourself. I mean, it's not that knowing pandas we are great, right? Knowing pandas and matplotlib or plotly or any scikit-learn, you need to implement on the data. Try to do that. So try working on data, spend more time on analysis and hyper tuning the models, do all that steps. So that's when we are, I mean, we are not like Python developers, right? We can't call us as Python developers because that's other specific of Python can be used for many things. So knowing Python means you are knowing, using Python, you can do something with the data. Using SQL, you can do something with the data. That's more important. So try doing that. That's when we more clarity on what would be required and how can we understand data. So that part I feel initially it would be taking time for anybody because that can't be taught as an course. I mean, I know people, we could say this is important, this is visualization, but when you do it yourself, that's when you know things. I've not explored AutoML much actually, but I would suggest probably I could study about it, but I'm not explored it as much. But yeah, yeah, we are getting more tools to automate things easier. All this is are there, but yeah, we need to go from the base, right? When we know things and we do it ourselves, we have more clarity. And once we are knowing things, but we could have these automated tools and all this be using. I mean, what to say? We could go there, but I would suggest. Try doing it yourself. Don't whatever things is possible, try doing it yourself. I've not experimented with AutoML much. Sorry on that actually. Yeah, that's about the questions. But given problem statement from a stakeholder, how do you access huge amount of data? How do you know how much data to use for ETA? Actually, I've explained that bit on actually. So it's more, I mean, it's not how much data, right? You can start with one day normally. You know what is happening with one day. You can have huge amount of data, but you need to have clarity on what you need to do first, right? You take one day worth of data, understand what is happening with that, and know, then increase your date size. And I want to see a timeline of month on month, week on week, and distribution on 2 months. All that will be exploring on that front itself, Santosh. Yeah. So it's like, I mean, we talked briefly about the applications, but yeah, so I'll just give you an idea, right? More about how a recommendation or a fraud detection, a customer segmentation, time prediction, demand prediction works in terms of any e-commerce, right? And how it's very important. So in any sense, right, you could take Swiggy, you could take Amazon, or any e-commerce world. You have millions of products. Probably we would have learned this Netflix. I mean, that's the, I mean, initial stages we could have always explore, right? The next recommendation algorithm. You could also take YouTube. That's the recommendation is the place. So showing the right things to right customers at the right time. That's very important. So that's where you have this funnel. You spread out this funnel. So as I was talking about that funnel example, right? Any e-commerce funnel, how do you increase that conversion? You keep the customer engaging, or in a YouTube world, but in an e-commerce world, you show the right product to the right customer at the right time, at the right price. So that is very important. So all the stages, you will be having this recommendation, showing the right things, right? So that's when you can increase this funnel size. So increasing this funnel size, you will be ending up with a good amount of orders. So that's your final target, right? So how do you increase this funnel size? Depends actually. So normally, probably let's say if you go to a listing page, you need to show right set of restaurants. That is very important. When you go to search, you could also search for any restaurant, but you need to have a right set of, based on your search thing, I need to show you a right set of products. That's when you go to the move to the next stage. And otherwise you could drop out in that menu, or even in the search stage itself. From the menu to cart, how do I make sure, even in menu you could have 100 items. So how do I show the right items to you and right offers to you at right places, so that you convert at all these funnel stages, and you end up with a good, the company gets a good conversion rate, and that's how it makes money, or have a good customer base. That's very important, right? So yeah, then the fraud detection space. Yeah. So that's very interesting space as far as I see, and I recently worked more on that space. So the interesting problems here, right? You normally end up with no label data. So that's when you try to explore a lot of strategies there, and lot many algorithms you try to use, and here going out with a one small misprediction, right? And it could lead to a lot of customer, lead to a very bad experience to the customer. Let's say you gonna wrongly say a customer as a fraudulent. It's same as the healthcare, right? I mean, not as severe as that, but you could say, let's say, I mean, you can't, if you are not able to predict a customer, I mean, a cancer patient. Let's say there is a cancer, you can't predict it, right? You end up, I mean, the life of the patient is involved, right? And it's not as severe as that, but if you are saying it, saying, you will not say it in the face, but when you say, when you predict that, it could lead a leverage. I mean, there will be an action based on that. That action could trigger a very bad experience for a good customer. So you need to be always right. Here you will be concentrating more on the precision than the recall. You need to be like 99% or 98% right in these cases. So I mean the precision should be on that ranges. So then on the customer segmentations bit, right, it will be like, it will not be a direct thing, but this customer segmentations will be used across different places. I mean, it's not just customer segmentation. It could be a delivery boy, delivery executive segmentation, restaurant segmentation. Based on that segmentation, you understand what marketing strategies should I use, or how much incentive should I give to a specific delivery executive group. So that is very important, and understand, as I was talking about the model understanding also, right? Once you develop a model, you will be also using customer segmentation. So how this model is performing on different customer segments. So let's say there is a high value segment, high order. Some people would be ordering high amount. Let's say they will not be a repeat user, but whenever they order, they will do a high value order. So there are different segments of groups. So how the model is performing on them, or let's say you'll be using that in different marketing segments, all that will be used. So then at the time prediction, right? So let's say in any application, e-commerce application, you will know how much time it's gonna take from order to delivered. In between that, right, you will have different stages. So let's say order to going to the vendor, picking up from the vendor to going to an nearby hub to delivering to an customer location. There are different stages of things, right? If you are able to predict this time, right, you can assign the things right. Let's say there are 100 orders today in any e-commerce. Let's say you're gonna ship these products. Let's say for shipping, this much time it's gonna take. So let's say that's when you can assign that let's say vehicle accordingly, right? Let's say there are 1,000 products gonna come today to this hub. You will know how much vehicles you will be needed to take that and deliver to the customer at the right time. So all will be dependent. So all these time predictions based on the problem, right? Swiggy will be dealing with an hyper local. So for us, the 30 minutes is also, I mean, the food will be delivered, I mean, on average 30 minutes. So even the 2 to 3 minutes change is also very important. So, but let's say for another generic Flipkart or Amazon, there could be like days, it takes some 2 to 3 days, or it could be take week also, but it depends every time. But the error is very important for all other assignments logic. And yeah, so then is the demand prediction, right? This is a very interesting problem and kind of bit difficult to solve also because we are dealing with millions of items, and not all items are getting sold every day, and sometimes it gets peak, sometimes it goes down. And this is very important for the inventory management on given in any world, right? For the preparation of a vendor. Let's say there is a restaurant, if you are able to predict the demand in, let's say, even a day ahead, you will know what all the requirements for him to be prepared. And if you are able to predict the demand right now, what is the demand for a restaurant going to be, you can send I mean, delivery boys could be might not be at the same location. If you can predict the demand 30 minutes ahead, you could spread out the delivery boys, delivery executives accordingly, so that you deliver the food at right time. So there are different applications, but yeah, I've just given a basic idea of things which we have and people solve. And people are also exploring on image and voice predictions, how to optimize on chats, and how do you assign chat agents at the right time, whom do you assign what. So it's not randomly assign a delivery boy to a customer. Does delivery boy know about that route, assign that delivery boy to that location. So there are many algorithms, problems people are solving in an e-commerce industry. So what I could also do is I'll share my email ID in the chat, and you could also ping me in LinkedIn. If you want to go deep understanding things, right? I mean, we could have an offline discussion. I'm happy to do that. I'd be really interested in knowing things. And one more thing, I'm also, I'm a person, I can't know everything, right? Probably if somebody knows things, people could share with me and we could discuss on that. I could also read about it and come back to you. And yeah, so that's the major thing. I shared whatever things I've experienced, whatever things I know. If I and you could also do that with me if something you feel something is not right or something you could be doing something better or it's a different way. That would be really helpful. And yeah, thank you very much. Probably I'll stop sharing my screen if there is any questions.
Thejasvee, thank you so much for this wonderful presentation and explanation on data science project lifecycle. It's been wonderful. And I am really sure that people have enjoyed this session, and there was a lot of interaction through chats and the questions. So definitely you can mention, you can write your email ID here in the chat box. People can make a note. And if they want to connect offline with you, they can.
Thank you guys. Thank you guys for attending this session.
Thank you, Thejasvee, and all the best for your future endeavors. And be in touch. We would definitely like to see you again for such interactive sessions.
Sure.
Thank you.
Thank you.
Thank you, everyone. Thank you.